Hello everyone, I welcome you all to my YouTube channel. Now we are into the third lecture for external lightning protection system, and in the previous lectures we have discussed about the concept behind rolling sphere and protection angle. Then in the just previous lecture we discussed about the how to design and how to use this protection angle method. Continuing the same, we will now solve the similar example for rolling sphere method. Now this lecture will give you the math behind rolling sphere method, which you will not find in any other places. Maybe you will find in some of the other sources, but it is not available and easily. And with this math, if you apply, you will not require any kind of software, and it's a very simple math which we have studied in school. So let us go and start. So this is our building which we saw the last time, and this is our reference, our mother earth. Then this is 7 meters long, and then we have an air terminal rod which was 3 meters in height. Now as we have used class 2, please note that we will use class 2 only here. As per class 2, the rolling sphere has a radius of 30 meters, which we have seen. It is available in IEC 62305-3. For those who have not seen the last lecture, I will just take back to them to that image. This is for your rolling sphere and this is for your protection angle. So rolling sphere class 1 is 20, class 2 is 30, class 3 is 45 meter, class 4 is 60 meters, and these are basically your heights in case you want to apply for protection angle. Rolling sphere is valid also for any point above this. So for class 2, 20 meter is the limitation for protection angle, but rolling sphere does not have this limitation. Similarly for class 4, 60 meters is the limitation, but rolling sphere does not have such kind of limitations. You can apply also for less than 60 meters, also for greater. It is the most preferred method, but not as per the standard, but global practices, because it is the most accurate one compared to the others. Now let us see. Last time we solved and we saw that 2 meters away this equipment, which is E1, and dimension of 1 meter, all the dimensions are in meter, I am not writing M. This is E1, which is 1 meter long, and we saw that protection angle was able to protect it because it had only a height of 5 meters. However, the protection angle was not able to protect in case it would have been 8 meters. But till this, let us suppose this equipment has length 7.5 meters now instead of 5 meter, and in case we go back to protection angle, we will find that the value was coming 7.8. So I will just draw this image once again. So this was the case. So at this edge you were getting this 7.8 meter. So that means it is still below. It is not, the equipment is only 7.5, but the protection angle is offering 7.8. So that means this is protected because it is lying in this pink region. That is the protection angle method's protection zone. Now we will use rolling sphere method, we will not use this method. So in case of rolling sphere, you have to roll a sphere, so you require this sphere to be like this and touching the tip. I'm sorry for this. So in this case, whether this is cutting this or not, that is what we have to check. So let us suppose we draw a rod of 10 meters. I will erase this and draw on a fresh page. So let us draw it here. This is 10 meter long rod. This is your surface, and then you have to draw a sphere of radius 30 meters. So let us suppose this is the sphere, now it is touching the ground, and this is the center. So it is, this distance is 30 meter. Class 2. This is again 30 meter. Please forgive me for my drawings. and let us suppose this is 10, it is just touching here, it has to touch. So now using coordinate geometry, this point is your origin, so this will become 0 comma 0. This is your positive x axis, negative x axis, positive y and negative y axis. So what will this point become for you? 0 comma minus 30. Please note that this is very important and this will help you understand the principle behind rolling sphere. And this point, so I will label this, this is O, this is A, and this B point is, it will be minus 30 comma 0 because it is x axis, y is 0. We know that this length is 10 meters. So from the top on the y axis, if you see this dimension, so this will be 20. So this point will become x, which we don't know, comma minus 20. Now we don't know what is the value of x because we only know the height. We don't know what is this distance. So this is what we have to evaluate now. How you can evaluate this without using any software? By using a basic mathematics. This is nothing but an equation of a circle. An equation of a circle which has a center at the origin is x square plus y square equal to radius square. Typically the equation can be written as x minus h plus y minus k is equal to r square, where h comma k is the center of the circle. However, as this h is equal to 0 and k is equal to 0, so you have the equation as x square plus y square equal to radius square. So now I will erase this just for not causing confusion. Now this radius we know, yes we know, radius is 30. So now the equation of this circle will become x square plus y square equal to 900. Now any point on this circle shall satisfy this equation, that is what we know. So this point is also on the circle, it shall satisfy, so we can evaluate the value of x1. So let us know that this point is point C. So point C has a coordinate x1 comma minus 20. We will put in this equation. So we get x1 square plus minus 20 square is equal to 900. So x1 square is equal to 900 minus 20 square or minus 20 square, which is 400. So which will give you 500, and that is x1 is basically square root of 500. So now this can be plus minus. So we will take the negative value because we are in this third quadrant. This is our third quadrant, so we will use the negative value from this. So if you do a square root of 500, you will get a value of, I will just do right now, you will get a value of 22.36. So x1 is basically 22.36 and negative of it because it is in the third quadrant. So now you have got this value. I will now write down the value of point C. It is minus 22.36 comma minus 20. Now we know this distance from this line, it is minus 22.36. Now we know that there was an equipment which we were thinking which was E2 and it is, let us suppose, E1, which is protected, let us suppose, and it is at a distance of 2 meters and this dimension was 1. So we will find the worst case, that is this edge point. So this point edge, let us suppose, is how many meters away? 3 meters away. So 3 meters away from this means it has a coordinate of, x coordinate we now know, it will be minus 19.36 comma y1 because we don't know the y coordinate. How can we know the x coordinate? X coordinate is, because we know x1 which is minus 22.36. So x2 will be minus 22.36 plus 3, which is this length, which I have colored in bold. So we got this value. Now we will substitute this. I will erase all this because we don't know whether this height is sufficient or not. So now we know the point where we have to check the height. So this y1 will give us now the value. So we will again substitute in this equation because this is lying in the circle. So again evaluating, now we know x, so we have 19 minus 19.36 square plus y1 square, and let us suppose this point is d. So I am using this d point minus 19.36 comma y1, which is equal to 900. So y1 square is equal to 900 minus 19.36 square, which is equal to 19.36, which is 374.8096, and subtracting these two will give us a value of, I'm sorry for this, 374 minus 80.96, it gives a value of 525.1904, and if you do a square root of this value, it will give you a value of 22.91. So y1 will be plus minus 22.91. We will choose the negative because we are in third quadrant. So now you have this value of y1 also with you, which is minus 22.91. So this minus 22.91 is from the top. If I write correctly, I'll use a different color. So this value you know is from this point, from the x axis. This is minus 22.91. So from the bottom it will be 30 minus of this. So this value will be, this height will be 30 minus 22.91, which is equal to 7.09. So you see the value is now 7.09. Now in this case, the height is, we assumed that the height was 7.5 meter, whereas the protection is only provided for 7.09. That means it is going outside the protection zone. So let us suppose protection zone is this. So this part is going outside the protection zone. So it is not protected. So whatever I have colored in green, this part highlighted in green, it is not protected because this length from here is 7.09 as we saw, whereas this length is 7.5. Now if you remember, through protection angle this length was higher, so that means the angle will be something like this. This curve is like this. So this is the extra oversimplified area that we were getting using protection angle. So with protection angle we were able to protect our equipment. I will draw a fresh figure. So this is our building, this is this. Through protection angle we are able to protect this equipment. Whereas through rolling sphere we are unable to protect this equipment. So now you have understood the difference between both the methods. So this part offered by protection angle is called the overestimated part, and this part which rolling sphere is offering and protection angle is not offering is called the underestimated part, and this both areas A1 and A2 shall be equal in order to decide the protection angle. This is what we studied in the first lecture. So in this case you can shift the equipment, change the height, and again solve and evaluate everything. So I hope you understand how to do this manual calculation. Now this is the worst case. Now there is a simple case about the equipment here. So we will take a completely different example. We will not relate the previous example here. But first we will commit the mistake that we committed last time. This is 3 meter, and these are the two rods. We seeing the cross section of the building, and we see that we have an equipment here, and this equipment height is around 2.2 meter. Why I am taking particularly 2.2 we will get to know later, but let us suppose this is 2.2. So whether it is protected or not we have to check. This dimension is given as 10 meters. We are choosing class 2, so radius of sphere is 30 meter. So let us provide a radius of 30 meter here. This is the sphere. This is 30 meter, this is 30 meter. Everything is in meters. Now, this rod is 3 meter, 3 meter. The sphere will penetrate a little from this line if you draw joining these 2 points. So this depth is called penetration depth. This D is called penetration depth. We have to check that this penetration depth is sufficient enough or is sufficient enough to avoid any clash with the equipment, so that the equipment lies within this protection zone. This will be your, I'm sorry, I will take a different color. This green part is your protection zone, and this will be your worst case. You can see that this length will be the lowest one. This will be higher, this will be much higher, highest. H1, H2 will be lower, H3 will be lower. Then this will again H2 again higher, and H1 higher. So H1 is greater than H2 is greater than H3. So we are checking what is the value of H3. If we successfully check the value of H3, which is the worst one, that is the midpoint, we will be able to solve. So now this is 30 meters. This is a triangle. Let us solve this. 90 degree. This is 10 meter. We are checking in midpoint. So this will become 5. This will become 5. So by applying Pythagoras theorem, this length L will be 30 square minus 5 square, which is 900 minus 25 square root. That means 875 square root, which is equal to 29.58 meters. So this is 29.58. This length, let us mark it as A, B, C, and this point as D, this point as E. So CE is equal to BD, and this is equal to 3 meter. Now we know that AB with us is 29.58. This is AB, which I am coloring in orange, and this is BD, which I have colored in red. We need to calculate this penetration depth, which I am coloring in purple. But we know that from this point A to this is the radius of the sphere. Let this point be F. So we know that AF is 30 meters, and AF is nothing but AB plus BF, and AB we have got 29.58. So BF will be nothing but 30 minus 29.58, which is 0.42 meters. So your penetration depth is 0.42 meters. So what is the value of F and D, which is what you had to find? F and D will be BD is equal to BF plus FD, and BD is equal to 3 meters, as you know from here, and BF is equal to 0.42 meter. So FD you have found is 3 minus 0.42, which is 2.58 meters. So that means your equipment, which was of height only 2.2, this was your equipment and it had a height of 2.2, it is protected because the protection angle is till this point, it is the worst case, and this worst case is 2.5 meters, 2.58 meter from this reference plane. So our equipment is protected. Now whatever we did here again is wrong. Not as the calculations, but we did not see the correct layout of this equipment. This equipment layout we did not see properly. Again, I would like to highlight, whenever you have to do calculations, always check the plan view. Here are also your 4 rods. From there you decide which section you have to take. Now let us suppose this was your equipment, this was 10 meters. So we were seeing the section x dash in this image. This section was for x dash and we were evaluating it, but it was not correct because we have to check this section, the mid one, which will cover this midpoint, and this is a diagonal length of, let us suppose, 15 meter. So instead of doing calculations for this 10 meter, we had to do for 15 because these are the furthest 2 rod. The sphere will dip more. So what I mean is, let us suppose this is 2 rods, this is only 10 meter. So the sphere was like this here, but if you extend this rod and you put it in this new, and you put a rod here and there was no rod here, this sphere will fall down. So this sphere will now become like this. So you see the penetration depth initially was this much, now the penetration depth has increased. So that means the protection initially offered was by the green part, but now as per the new, it will be offered by the red part. So that means this area which we had calculated, this area which we had taken was not correct. So now we will reevaluate and solve for 15 meter using the same methodology which we did. And we will check whether our equipment is able to sustain it or not. So this is our rods. Again we will apply the same method. Sphere, rolling sphere. This is 30 meter. This is also 30 meter. This is 90 degree. This is 3 meter. This is 15 meter. So midpoint we will have to check which is the worst case. This is 7.5, 7.5. So this length, which we will take the same values, A, C, and B. Okay. This was A, this point was B, this point was C, E, this point was D, and this point was F. So now AB will be, by Pythagoras theorem, 30 square, square root of 30 square minus 7.5 square, which will give you a value of 29.05 meters. So now it is 29.05. Earlier it was 29.58. So now you can see AF is nothing but the radius. This is AF, which is the radius. So AF is equal to 30. And AB you have calculated 29.05, and AF is equal to AB plus BF. So we got the value of BF as 30 minus 29.05, which is equal to 0.95. So BF is 0.95 for you. Now BD, you knew it was 3 meter, which is same as CE, minus 0.95. If you do, you will get FD. So FD is nothing but BD, that is this length, minus this length, penetration depth, will give you FT. So red minus orange will give you green. So we get this value as 2.05. Now you remember we took the equipment dimension as 2.2. So this equipment will not satisfy. The equipment is a bit longer and it is falling outside the protection zone. So protection zone is defined by this pink, and what is the unprotected area? I will color in purple. This is the unprotected area now. So that means we are not able to offer correct protection. What we can do, again as we saw previously in protection zone, you can increase the height of this 3 meter by not increasing the copper length. You can place it on the parapet walls. If they are parapet wall here, you can increase the height of 3 meter rod by 1 meter or 1.2 based on the height of the parapet. If you don't have parapet, then you can place these rods on a concrete block, on a concrete foundation, in order to increase the height by whatever is required by you. So you can check, calculate, okay, penetration depth is sufficient, so you can evaluate accordingly the height of this foundation. 0.5 meter, this will make the length to be 3.5. If that also is not satisfying, you have to provide a rod in the middle. So sometimes you will see there are some rods, if this equipment is not exactly located here, sometimes these equipment are here, so you have to provide a rod in the middle. First you will evaluate this by taking this diagonal length, by taking this cross section. You will check whether the penetration depth is satisfying or not. If you know this exact dimension, how much far away from it is there, and this obviously you will have in the AutoCAD, then you can put the exact values here and solve. If it is not satisfying, then provide a rod in the middle. By providing a rod in the middle, this 15 will reduce to 7.5. So there will be a rod here. So this sphere will be like here and the other will be like here. So it will be protected. We'll draw this in red. So these two spheres will be there by the rod in the middle which you have provided. So this area will become protected. So the new area protected will be this blue part. So your region is being protected. So I hope you understand the basic concept behind rolling sphere, how to solve, how to evaluate. You can practice with your daily examples which you encounter, and I hope you enjoy this lecture and meet you in the next one. So till then, God bless you all.